Hello viewers, welcome to another episode of knowledge sharing. For today, we are looking at this question and it says solve for a in 2 to the power of a plus 4 to the power of a equals to 8 to the power of a. So we are going to evaluate this and solve for the value of a from this equation. Here we are given 2 to the power of a plus 4 to the power of a equals to 8 to the power of a. From here, what we need to do is for us to divide all through by 8 to the power of a. So we say divide all through by 8 to the power of a. So doing, this will become 2 to the power of a all over 8 to the power of a plus 4 to the power of a all over 8 to the power of a equals to 8 to the power of a all over 8 to the power of a. This will cancel here 1 and this will cancel here 1. We are now having 2 all over 8 all to the power of a plus 4 all over 8 all to the power of a equals to 1. Why we have this? If we have a to the power of x all over b to the power of x equals to, it can be written as a all over b all to the power of x. So this is why we have this. So doing, here 2 can cancel here 1 and 2 can cancel here 4. This one, 4 cancel here 1 and 4 cancel here 2. So we are now having 1 all over 4 all to the power of a plus 1 all over 2 all to the power of a equals to 1. Here, 4 is the same thing as 2 to the power of 2. So doing, here will become 1 all over 2 to the power of 2 all to the power of a plus 1 all over 2 all to the power of a equals to 1. So this can be written as 1 all over 2 all to the power of 2. Then all to the power of a equals to 1 all over 2 all to the power of a equals to 1. So we have to the power of 2 here inside the bracket and also to the power of a. We can interchange each other in the sense that when we have a to the power of m all to the power of n is the same thing as a to the power of n all to the power of m. So we can interchange each other. So doing, here we can rewrite this as we have here 1 all over 2 all to the power of 2 all to the power of a equals to 1 all over 2 all to the power of a equals to 1. So by interchanging this will become 1 all over 2 all to the power of a bracket all to the power of 2 equals to 1 all over 2 all to the power of a equals to 1. You can see that here we have 1 all over 2 to the power of a and 1 all over 2 to the power of a. So we say let y equals to 1 all over 2 all to the power of a. So here we will have y to the power of 2 plus, okay, here is plus, here we have plus. So here will be plus y equals to 1. So we need to transpose 1 to this other side. So we have y to the power of 2 plus y minus 1 equals to 0. So this has turned out to become a quadratic equation. So we are going to use a quadratic formula for us to find the value of y. So doing, y will be equals to minus b plus or minus square root of b to the power of 2 minus 4ac all over 2a. So doing, the value of our a equals to, here is 1, value of b equals to 1, and value of c equals to minus 1. So substituting this parameter into where we have this, y will be equals to minus b, which is minus 1, plus or minus square root of b squared is 1 to the power of 2 minus 4 times a, which is 1, times minus 1, which is c, all over 2 times 1. So this is what we have. So in that case, we have our value of y equals to, this is minus 1 plus or minus, we have square root of 1 squared is 1 minus, we have minus 4 times 1 times minus 1 will become plus 4. So we have plus 4 all over 2 times 1 is 2. So our value of y will be equals to minus 1 plus or minus square root of 5 all over 2. So here y has two solutions because it contains plus or minus. So here the first value of y, which is y1 equals to minus 1 plus square root of 5 all over 2. Then we have y2 as minus 1 minus square root of 5 all over 2. So these are the possible value of y that we have from this equation. We recall that we had our y equals to 1 all over 2 all to the power of a. So we are going to substitute y into each of these for us to find the value of a. Before we do that, we need to clean this. So as we said, the possible value of y, that we have y equals to 1 all over 2 all to the power of a. We are looking for the value of a. In this situation, then let's say let's take this and let's take this to find the value of a from the solution of y. Before we do that, we need to check whether each of these, the one that has real root and the one does not have real root. Okay, we can take one after the other. So here will be from y1, where we have our value of y is 1 all over 2 all to the power of a equals to our y1 equals to minus 1 plus root 5 all over 2. So this will become minus 1 plus root 5 all over 2. What we are going to do next, for us to find the value of a, we need to apply log to both sides. So we'll say apply log to both sides. So this will become log 1 all over 2 all to the power of a equals to log minus 1 plus root 5 all over 2. So here we recall that, say note, when we have log a to the power of x is same thing as x log a. So we express this in this format. So this will become a log 1 all over 2 equals to log minus 1 plus root 5 all over 2. So here we can divide both sides by log 1 all over 2. So this will become a log 1 all over 2 all over log 1 all over 2 equals to log minus 1 plus root 5 all over 2 all over log 1 all over 2. So doing, this will cancel here 1 and this will cancel here 1. Therefore, we have the value of a from that equation as a equals to, because this cancel here and this will remain log minus 1 plus root 5 all over 2 all over log 1 all over 2. So we recall that we say note, when we have log a all over log b is same thing as log a base b. So we are going to express this in this format. Therefore, our value of a equals to log minus 1 plus root 5 all over 2 base 1 all over 2. So this is the value of a that we have. Let us check for the next one, which is for the y2. Our y2 was y2 equals to minus 1 minus root 5 all over 2 because we were taking from here. So for the value of y2, when we recall that our y, okay, we say from y2, which is equals to minus 1 minus root 5 all over 2. Then we recall that our y was equals to 1 all over 2 all to the power of a. So doing, we substitute the value of y into here. We have this will be equal to minus 1 minus root 5 all over 2. So doing, we can see that we have 1 all over 2 to the power of a. So this is going to be positive. And this other side we have minus 1 minus root 5. So this other side will be equal to negative. So doing, positive cannot be equal to negative. Therefore, the solution of y2 does not have a real number, so it's rejected. So y2 is rejected. So what we are now left is the y1, the value of y1 that we have, that a equals to log minus 1 plus root 5 all over 2 base 1 all over 2. So this is the value of a that satisfies this equation. If you like what we're doing here, follow us on our Facebook page, subscribe to our YouTube channel, comments, and share our video for more interesting topics. Thank you.